Hi and good day everyone. Welcome to Hosey How To channel, where I share real project experiences for better skills that will lead to a higher pay career. Today, I would like to share with you how to avoid common pumping system design errors, part 1 of 4. When we design a pumping system, we always want to ensure that the operation of the pumping system shall run efficiently and without any problem. There are many common design errors one can make in the pumping system. Not knowingly, these can cause significant operational problems or inefficiency to the system. I have divided this topic into a few parts as below, and this is part 1 of 4. Part 1 of 4. The common errors made on pipe and fittings, such as fitting, butterfly valve and non-return valve installation orientation. Part 2 of 4. The common errors made on pipes' straight length requirements for equipment such as pump, non-return valve and flow meter. Part 3 of 4. The common errors made on suction sump design, such as minimum submergence, turbulence and water levels. Part 4 of 4. The common errors made on pipe velocity. I hope these videos will give you some insight in designing a pumping system to avoid those common errors and learn something new at the end of the videos. Please subscribe and like my channel before we go further. In this session, we will touch on the common errors on the fittings and valves installation orientation, particularly on the suction reducer, butterfly valve and the non-return valve. What are the common errors normally seen in these installations? For suction reducer, it is normally used to reduce the pipe diameter from a larger size to a smaller size at the suction side of the pump. The pump suction flange is normally smaller by 1 or 2 diameters than the suction pipe diameter. Therefore, one side of the reducer is larger, and the other side is smaller. The reducer can be either a centric or eccentric reducer, as can be seen. The common error normally made by a designer is either to suggest a centric or an eccentric reducer with the bottom flat orientation. This orientation will cause the pipe not to be fully filled, as the air will be trapped on the top of the reducer. The solution to this common error is to use an eccentric reducer but with top flat orientation. This orientation will not allow any air to accumulate at the top of the reducer, as it is flat. For butterfly valves, the valve has a spindle across the valve bore. The common error made by the designer is to arrange the valve with the spindle vertically, where the bottom of the spindle is located at the bottom of the pipe. This orientation will easily cause the debris or particles to trap at the bottom of the spindle. After a long period of time, the debris will continue to build up and accumulate until the valve operation is blocked and could not be fully closed. To overcome this common error, designers should specify that the butterfly valve shall always be installed horizontally, as can be seen in the photos. This would allow the water and debris flow through smoothly. For a non-return valve, this is an important valve to prevent any backflow from the network or rising main when the pump is stopped or idled. The common error made by the designer is installing the valve vertically in the piping, particularly for a swing-type non-return valve. Vertical installation may cause the valve not to fully close. To overcome this common error, we should always install the swing-type non-return valve horizontally by ensuring the flap works properly. The swing-type non-return valve working principle is to close the valve based on the flap weight. That's all for today's session. Please continue to watch part 2 and other parts of this series. Please don't forget to click the subscribe button and like my channel. Thanks for watching.